By the name of Almighty God, the most compassionate and the most merciful, I welcome all of you, my dear friends, to your own channel. My name is Nasir Ibadi from Afghanistan. Today we are talking about discovery of electron. First, I will write the aims or the goals that we are talking about. And second, we will proceed, inshallah, our lesson. The main purpose we are talking about is first, discovery of electron. Discovery of electron. This is our first topic. Second, we will talk about ratio of E upon M, which is a constant ratio, and that one is 1.758820 times 10 minus 11 coulomb per kg. This is the 10 to not minus 11. And also we will talk about the charge of electron. Charge of electron, which was discovered by Millikan. This is our own topic for today. I'm sure that you will not get tired. Please have a notebook, and whatever I'm telling and I'm explaining, write it down on your notebooks. Okay? Are you ready? Should I erase the board? Okay. The previous lecture that we had, it was about atomic structure. In atomic structure, we explained John Dalton theory. It was the first theory which talked about the atom, and he explained that atom is the fundamental part of a matter which is not divisible. It means which is uncuttable. But after this one, there was another scientist by name of J.J. Thomson. J.J. Thomson, he explained that the atom is not the fundamental part of a matter. In the atom, we have negative and positive charge. We have negative and positive charge. Now, how he explained his atomic theory, before going to J.J. Thomson's theory, we will talk about discovery of electron. How electron discovered, and what is the property of an electron. First, we have to explain this one, and second, we will go inshallah about J.J. Thomson theory. Okay, are you ready? MashaAllah. Now, discovery of electron. Please write this topic. Discovery of electron. Discovery of electron. Okay. J.J. Thomson, he explained that whenever we take an evacuated tube and we put some gases in this tube with a low pressure, a current, by creating a high voltage, a current is made from one part, from negative side, it means from cathode to anode. Now, how? Thomson, he said that whenever you are getting an evacuated what? Tube, he sealed in here one plate of a metal and also another plate in here. Then he connected this one to a battery which has a high voltage. maybe around 10,000 volt. 10,000 volt. Also in here we have this tube like this one, and we have something here in order to control the what? The gases which are in this tube. This is an evacuated tube. In here we put some gases, maybe hydrogen, maybe oxygen, or maybe whatever is that one. Now, in order to study the property of atom, we should lower the pressure. Why? Because by lowering the pressure in here, we have a less amount of the gases. For example, we have like this one. Now we have less amount of the gases whenever you are lowering the pressure. Maybe around 0.001 millimeter mercury. Maybe around this one. And with a high voltage. Now this plate is negative and this one is positive. It means this plate is connected to this one. So it is negative. And now the second plate is connected here. It is positive. Positive. And this one is negative. Now what do you think? That this plate, which is negative, what is it called in chemistry or physics? We call this one cathode. Cathode, the plate which is negative charge. And the second one is called anode. Whenever I'm talking about anode, anode means positive plate. And whenever we are talking about negative plate, we can call this one cathode. Now, by connecting these two plates with a high voltage, in here a current is generating. Through the help of these gases, with the connection of high voltage, between anode and between cathode, a current is generated by the help of these gases. Now, current needs the flow of the electrons. Current needs flow of electron. If this atom is neutral, then we don't have any current. But if we have something charged in this neutral atom, so it means the current is generating. What do I mean? If atom is neutral, it means if it doesn't have any charge, which Dalton said, then there is no current. But if we have something charged, maybe negative, maybe positive, or maybe both of them, it means a current is generating here. Since this current is generated, in order to know that do we have any current or not, J.J. Thomson, he coated this side with a fluorescent material. He coated this side, it means he covered this side with a fluorescent material. I think it was zinc sulfide. Now we have here, what do we have? We have coated here with a fluorescent material, which is zinc sulfate. Why we coat here? Why we cover this one? In order to know that do we have any current through these atoms or not. Also, this plate, it is like this one. Indeed, it is two-dimensional, and we have holes here. Also, this one is 2 dimensional. It is not 1 dimension. It's indeed like this one. He generated some holes in positive plate, and also he covered this side with what? With a fluorescent material, which was zinc sulfide. Now, if we have current from negative plate to the positive plate, it means there are something which is going from negative side to positive side. If there is something which is going or which is flowing from negative side to the positive side, indeed it will go through these holes, and so we will have here some white spot in the what? In this covered or coated fluorescent material. If we have some glows in here, if we have some spots in here which is glowing like a white color, it means there was something which was entered from these holes and strike with this plate. It means we have something in what? In these atoms. Why he lowered the pressure? Because if he didn't lower the pressure, on that occasion, maybe this atom and this atom, they will strike with each other. By lowering the pressure, these atoms of the gases will be in a distance. Now, it will be in a distance, so in that distance, we won't have this possibility in order to strike with each other. Now it means there is something in atom. He summarized this story. In following details. First, he said that there is something which is going from negative plate to the positive plate. Negative plate is called what? Cathode. Now the things which are going from the negative to the positive, he nominated that one cathode ray. Cathode rays. What does it mean? It means there is something which is coming from the negative plate to the positive plate. There is something which is coming from negative plate to positive plate. Second, this ray which is going from negative plate to the positive plate, it is invisible. For this result, he covered the side with a fluorescent material. It means by zinc sulfate. Now from the spots which was made through this current and by helping of high voltage and lowering of the pressure of the gases, so we are sure that there is something which is coming through these holes, and it is invisible. Number 3, these things which are going from the negative plate to the positive plate, they have kinetic energy. They have kinetic energy. Why? Because he put a wheel here, and this wheel got motion. it means a motion was generated. Why this one is generated? Because there is something which is striking in here and it creates motion. It means that this one is these things, whatever is that one, these things have kinetic energy. Number 4, they travel in a straight line. But when we put what? But when we put, for example, a electric field like positive and also negative electric field, now these particles do not travel in a straight line. They what? They once again I'm repeating, when we put the positive plate and negative plate, it means electric field, they do not go in a straight line, they deviate it from its own path. It means we have a deflection. Once again, if we put electric field and also by magnetic field, it means if we put in here, for example, south, and we put here north of the magnetic field, now these things which is called cathode rays, they deviated from its own path and they will deviate it through south pole. When we put the positive plate and negative plate, it means electric field, then they deviated to the positive plate. It means electric field and magnetic field, they have what? They have what should I say? With the negative plate and by helping of positive plate, or by using of B and by using of north and south, they have its influence on going of the electrons. It means on motion of the electrons. It means by using of electric field and magnetic field, they deviated, or we should say we have deflection in the motion. And number 6, Thomson changed the gas. First he put it, for example, hydrogen. Second he put oxygen. Third he put nitrogen. Whatever the gas is, by high voltage and also by lowering the pressure, he said the same characteristic in all gases. Once again I'm repeating, when he changed the gas, first he put nitrogen, second he put another gas, third he put another gas. Now it means that these particles, they do not depend on the characteristic of the gas and also on the characteristic of the plates. These particles do not depend on nature of what? these electrodes and gases. I'm repeating. When he changed the gases, he changed the materials, which is cathode and anode, by putting this voltage and characteristic of the and by putting electric field and magnetic field, there was no change in these conditions. It means when he put oxygen, he saw the same things. When he put another gas, he saw the same things. When he put another gas, he experienced the same things. Now, what's the conclusion? He said that atom is not fundamental constituent of matter. He said there is another thing which he named electron. Electron is the fundamental constituent of matter. Can we see the board? Yes. The last one is matter. He concluded that there is something in these atoms, which is same in every gases. And these things, which he called at the first by name of cathode rays, he nominated electron. Electrons are the basic or fundamental constituent of the matter, which we have in every atom. It means in nitrogen we have these things. In oxygen we have these things. In sulfur we have that one. Maybe the numbers are different. In hydrogen we have that one. In helium we have that one. The first scientist, John Dalton, he told the first fundamental of everything is atom, and it is neutral in charge. But now J.J. Thomson, he discovered that there is something which does not depend on the nature of the gases and on the nature of the plates. These things, this one, which has negative charge. Why negative charge? Because it's moving from negative plate to the positive plate. So this one is called electron, and electron is the fundamental constituent of the matter. I think you have got. Now we are coming about, and we will talk about a ratio of E upon M, charge of electron and mass of electron, inshallah. Write it down, please. Okay. Now we are talking about the calculation of E upon M, which is a constant number. Before talking on the calculation of E upon M, One thing, I should explain this diagram for you. First, we have this one positive plate, this one is positive plate, and this one is negative plate. And here we have the gas. Now, by connecting this one to a high voltage, a current is generated from negative side to this one is cathode or cathode, and this one is anode. It means positive plate. Now, a current is generated from the cathode to anode, and this cathode is called cathode ray. This current is called cathode ray. Now, we have a hole here. The cathode rays is entering and passing this anode plate. Whenever it passed, in here we have one is electric field, positive and negative plate, and also we have magnetic field. We have south pole and also north pole. In the absence of the magnetic field and also electric field, the cathode rays goes straight. It goes straight. But whenever we have the electric field, this charge, which is negative, it turns to positive side. It behaves like charges. You know about the charges. The charge, you know, Coulomb force. Charge, if we have like charge, what do you mean by like charge? It means same charge. They repel each other. For example, negative and negative, they repel each other. Positive and positive, they repel each other. And number second, if we have unlike charge, it means different charges. For example, for the negative and positive, they attract each other. Also, negative charge attract to the positive, and so negative charge is attracted in magnetic field to the south pole. Now, if we do not have this field, electric field, and we have just magnetic field, the cathode rays strike C point. If we have electric field, it will strike A point. If we do not have both of them, the cathode rays will pass in a straight line, and it will strike B point. One thing more, that in here electric field and also magnetic field, they are perpendicular to each other. It means we have, for example, this one is what? This one is electric field and this one is magnetic field. Now what do you think? If we have this one electric field and this one magnetic field, the cathode rays is also in X, this one is in Y axis, and this one is in Z axis. It means in here the electric field, the magnetic field, which are perpendicular to each other, these two electric field and magnetic field, they are both perpendicular to the motion of electron also. Electron is moving in X direction. Electric field, they are in Y direction. And magnetic field, they are in Z direction. Now what do you think? They are perpendicular with each others too. The deviation in here, which is made by electric field and magnetic field, It depends on what? The deviation which we have, this deviation and this deviation. It depends on what? First, deviation or this turning, or deflection, whatever you say. This deviation, first, it is directly proportional to magnitude of the cathode rays. Magnitude means amount of electrons, which we say cathode rays. If we have much electrons in here, now they will interact it with the electric field and also with the magnetic field. Once again, the deviation is directly proportional to the magnitude of the electrons. Why? Because if we have large number of electrons, they will be interacted with the what? With these plates. It means with the electric field or with the magnetic field. Second, the deviation is inversely proportional to the mass of electrons, the mass of this one. If this is a light particle, the deviation will be much more. For example, there is something which is going in a straight line, and there is something which want to pull this one, to itself. Now what do you think? If this one is light, it will bend much more. But if this one is a heavy particle, it will be very difficult for this field in order to bend. It means for the lighter particle, the deviation will be more, and for the heavy particle, the deviation will be less. It means deviation is inversely proportional to the mass of electron. Number 3. Number 1 we have got, number 2 we have got, and number 3. The deviation is directly proportional to the strength of E and B. What do you mean? It means if we have this one very powered, on that occasion this deviation will be much more. For example, there is something which wants to go in a straight line. In here we put an electric field which is positive. Now if this one is more strengthened, it means maybe, for example, with a high voltage. On that occasion, with a high voltage or with much more strength, this electron will much be deviated or turned to this plate. But if we have lesser strength, on that occasion the electron which wanted to go in a straight line, it will deviate but not as much as this one. Now, by collecting this information, we are able, in order to calculate the E upon M, which is a constant number. How? Try to copy. First, please. Okay, listen. How many fields do we have in here? we have two fields. First, electric field, and number second, we have magnetic field. Do we have this one or not? Yes, actually we have. Whenever we are talking about electric field, this deviation, it becomes from the electric field. Now, the small particle, which was electron, it was going a straight line, but by putting this electric field, it deviated from B point to A point. Now, the electron is going, it means it is in motion. Whatever is in motion, it means it has what? Kinetic energy. Then kinetic energy will be 1 upon 2 mv square. We have this one. Second, the electron's path was to B, but we worked on that one by using of this electric field, and it got the position of the A. It means we worked on this particle. Now it means whenever you are working on a particle and leaving that one to another place, it is called potential energy, which is called volt, and that one is work done upon charge, and this charge is electron. Whenever we have this one, V volt, work done upon E. Do we have this one or not? Yes. Now, by equating two sides, we will have work done EV, which is potential energy. And by equating this side and this side, this is also energy, this is also energy. And by equating these two equations, E equal to 2, another side will be same. It means 1 upon 2 mv square is equal to EV. What do you mean by this V? This V means volt. What do you mean by this V? This V means velocity. This is voltage, which is clear for us. Why? Whenever we are putting this electricity, it means we know the voltage of this one. We are talking about electron. In here, electron is variable. Voltage, we should know. And we should know the what? The velocity also. Okay. Now, I want to have the solution for velocity. What should I do? We use V square. Now, if we product 2 in two sides, this 2 will be finished, and here we have 2AV, you know this one, and M is going to this side. And now, by checking the square root, we will have V is equal to square root 2 EV, which is volt, upon M. Now, this is our first equation. Second, whenever we are coming to the magnetic field, by using of what? Lorentz law, we have force is equal, according to Lorentz law, force is equal to Q VB. cross B. Now, what is Q? Q is electron charge. It means F is equal to E V. What do you mean by V? V is the velocity of the particle. And what is B? B is the magnitude field, or magnetic field. Now, what do you say? The velocity of the electron and the magnetic field, they are perpendicular to each other. And this is a vector product. Why? Electron is going through this side, and magnetic field is like this side. It means it is in one direction, and the second one is perpendicular to that one. In here we have the magnetic field like this one, and we have the electrons which is going in X, and this is in Z direction or Y direction. They are perpendicular to each other. Now, if they are perpendicular, the product, vector product formula is V. This is a vector quantity, velocity. B is also as vector quantity, and the magnitude is VB sine theta. VB sine theta, and theta is 90 degree. Why? The magnitude and the motion of the electron, they are perpendicular to each other. So we can say that this one is 90, and it becomes E V B sine 90, and sine 90 is 1. So F is equal to E V B. Now this is our first equation, which is the force of what? Magnetic force according to Lorentz law. Now, if in here, please let me say something more. Whenever we have this magnetic field, now the electron is in X direction, the magnetic field is here. What do you say? This electron is striking B point. It means it is turning. It means we have a circular motion. Please, we have this one. This is magnetic field. If we don't have magnetic field and electric field, electron is going a straight line, and it will strike B point. But if we put this one, by using of this electron is striking here. It means it is turning around to magnetic field. It means we have a circular motion. In circular motion, we have force of centripetal force is, we have this one according to physics, mv square upon r. We have this equation also. Now, centripetal force is not one kind of force, but there is a force which is acting like centripetal force. Once again, we don't have any types. It means a centripetal force is not one kind of force, but a force is acting instead of centripetal force. For example, we have in tension, we have this rope. Now there is something, and it is making a centripetal force. It's making a rotation. Now this rotation is made of what? This is made of this force, and this force is centripetal force, and this centripetal force is tension. For example, we have sun and we have earth. Earth is going round or ellipse around the sun. Now what do you say? Is there any force which is doing this one? Yes, it's a centripetal force. Now, what works instead of centripetal force? It is F, gravity. The gravity works instead of centripetal force. It means centripetal force is not a type of force, but there is a force which is working as centripetal force. Now, the general formula for centripetal force, we have F centripetal force is equal to mv square upon r. Now, what do you say? This force of the magnetic, which is Lorentz force, it is making a rotation, and this rotation is what? Centripetal force. And this centripetal force is in here. This centripetal force is Lorentz force. It means magnetic force. Now, by equating these two, which are same, another side will be E V B is equal to m v square r. Now, I want to have E upon m. This m, we put this one in here, E upon m, and VB is coming here with the r, v square v b r. We can cancel one v, and we have E upon m is equal to v b r. Now what do you say? What this one v is? It's velocity. B, magnetic field. R, radius. R is radius. Where should I write it? V is velocity. B is magnetic field. And R is radius. For example, from this point, it comes here. We have rotation. Now we can calculate the radius. And also M, mass of electron. Mass of electron. And this V is voltage. Now, we are putting this in here. Before putting, E upon m is equal to VBR. We are putting what? That's velocity, E upon m. We are putting this one there. Now the equation is, let me take another marker. If we say this is 2 star equation, now by putting 1 star and 2 star, we have E upon m is equal V, velocity, square root 2 EV m BR. BR. Now, by squaring both sides, we have E square m square is equal to this one 2EV m B square R square. B square R square. Now this is coming here. E square m square 2EV m B square r square. Listen here. This one is cancelled with this one, and 1m is cancelled here. Now we have em is equal to 2v b square r square. Now v is what? V is voltage. V is voltage, which we know what this one electric field has the magnitude. What is B? B is magnetic field, which is known. What is R? R is also radius, which this one turns and makes a rotation. This is also known. Now V is known, B is known, R is known, and this one is a constant. It means E upon M is a constant, which is 1.758820 times 10 to the power 11 coulomb per kilogram. We have proved by using of magnetic field and also electric field the value of E upon M, which is same in every matter. This was the conclusion that J.J. Thomson made it. Now, what's the charge? The charge was proved with a scientist by name of Millikan with the help of oil drops. We will not discuss here, but if you wanted to know, you can go on YouTube's. We have great teachers that they have proved the magnitude of the oil drops, the magnitude of the charge of electron with the help of oil drops. But I will write that charge. What is that one? Let me see. The charge of the electron. Where should I read? Where should I write? Here. Charge of electron. Electron charge. It is 1.6. Let me see the book. 1.6 to the power 1.60202176, I think. Times 10 to the power minus 19 coulomb. And this charge is negative. This is the charge of electron, which was proved by Millikan by usage of oil drops. If we have this one, the electron charge, now what do you say? Can we have the magnitude of the mass? Yes, why not? If we put here E 1.602176 times 10 to the power minus 19 coulomb. If we put here, this is known, then we can find the M. The M is mass of electron is equal to 9.1794 times 10 to the power minus 27 kilogram. This is the mass of electron, and this one is the charge of electron. Millikan proved this one with the oil drops. By usage of oil drops, he equated the magnetic field, the electric field, with the gravity field. And here we are not talking. Just try to memorize this one. What's the electron charge? What's the electron mass? and the ratio of E to M is 1.75 8820 times 10 to the power 11 coulomb per kilogram. Write it down, please. Have you finished? It was our today lecture. Wait for our next lectures. We will come soon, inshallah. Allah Hafiz.